Okay, this is on the structure of the atom. We learned about Dalton's atomic theory. There were problems with Dalton's atomic theory. One of the major things is that it considered atoms to be hard, indivisible particles, which means that there's no proton, neutron, or electron. And since they're indivisible, it couldn't explain why atoms reacted. It also did not explain why atoms had varying abilities to combine with each other. So it couldn't explain why you had CO2, carbon dioxide, and also CO, carbon monoxide. Because once again, if it was indivisible, then you couldn't do that. And since you did know about the protons, neutrons, electrons, you couldn't explain why they were bonding. So because of that, it was a need for new theory. It was a good start. Dalton starts us on the path. That's when we recognize him, we pay attention to what he has. But it wasn't good enough for us to use even today. So there was a need for new theory, and continued research led to the nature of the atom after 1885 and led to the understanding of the atomic structure. One thing you need to understand about chemistry, unlike other sciences, chemistry went through a massive boom in the 1800s going into the 1900s. That's one of the impressive things. We'll talk about quantum theory later. But chemistry is a relatively new science, and there were a lot of developments real quick on it. These guys here you should recognize: Becquerel, Thomson, Rutherford, Chadwick. You did a timeline earlier. You're going to go back and add these guys on because these guys are important to our understanding of this new theory. Parts of the atom. You come in here and you should know protons, neutrons, and electrons. Okay? You should know where they're arranged at. We're going to go back through and we're going to talk about the scientists who were in charge of discovering those. The number and arrangement of these three particles, determines the nature and properties of the different kinds of atoms. And we're going to see that soon. You're going to have a full understanding of the periodic table beyond what you thought you know. The electron was discovered by J.J. Thomson in 1897. It's represented with a negative sign, with an E, or an E minus. I will use all three of these, so get used to that. It has a mass of only 1/1837 that of the hydrogen atom. We reference everything back to the hydrogen atom. It's one of the most abundant elements in the universe. It's the first one that was out in the universe. Hydrogen fused together to make helium, and that process continues on until we have most of our elements on the periodic table. The name is actually derived from a Greek electron, which means amber. Okay, this whole idea came from rubbing a piece of amber with fur or wool. It attracted light objects. You've done this before when you've rubbed the object, rubbed a balloon on your hair and stuck it to the wall, or maybe you took a comb and rubbed it through your hair and had a thin stream of water, and you've put the comb nearby and all of a sudden the water moved. The cause of attraction is electrical charge, and they were able to see that. I will have you look over his experiment and what he did and the cathode ray. Protons, discovered by Ernest Rutherford. You should know his experiment. It's called the Goldfull experiment. Again, we're going to represent a proton with a positive sign with a P or a P positive. The charge is equal and opposite of an electron, but please note here that the mass is 1836/1837, that of a hydrogen atom. So they may be totally different in their masses, but the fact is they are equal in charge between the electron and the proton. Okay, you'll watch the Goldfull experiment later. Neutrons, discovered by James Chadwick. You'll notice that this was discovered in 1932. The proton was discovered in 1919. So there's a long time frame between the two, and of course, it makes sense that it's discovered last because it's neutral. The whole idea is that they knew there was something more massive in there. They couldn't explain it, and so since they couldn't explain it, they just weren't satisfied that they had everything there. And so this guy comes along, and he finally figures out that the neutron is there. It's also represented with the electron with the letters N, 0, or into the 0. They have no charge, thus they are neutral. It has about the same mass as that of a proton. We'll also learn later that these are responsible for isotopes. So here's the summation. This is important. This should always be in your notes. This is a great reference tool. So we have our particle, symbol, charge, mass in AMU, and location in the atom. Electron, we have our three symbols. It's negative or -1. We have its mass in AMU. This is atomic mass unit. We'll talk about that in a little bit. It surrounds the nucleus. We have the proton and its three symbols. It's positive plus 1. Here's its relative mass in AMU. And it's inside the nucleus. And then we have the neutron. Its three symbols. It's neutral, and here's its mass, and it's inside the nucleus as well. Okay, I'll come back and give you some more information. Bye.